Today we've got a big build for you. We're going to use a 3D printer to produce an item that'll generate electric power for us. Everything you see here is what we're going to need to print out to build a wind generator with our 3D printers. We're going to mix this up a bit. We're going to use a few different materials, and we're definitely going to use a few of our machines up here to build all these different pieces and to make sure that they're made out of materials that are going to handle the wear, the tear, the weather, and the heat that potentially they could come in contact with. The parts that you see here, obviously we've got 5 wind blades over here. Then we have pieces to our nose cone. So this is the main part of the nose cone. This is the actual rotor piece that the blades are going to mount into. This piece here is the pole mount that's going to mount to the bottom of our main part of our case. This here is our main case, and I'll change the perspective for you here in a moment so you can see these a little better. This is the front cap to our main case. This is the rear cone to our main case where the piece of pipe is going to come out of that goes to our rear vane here. And then here, these two pieces are our rotor and our stator for making the electric power part of our generator here. And then we've got a permanent magnet rotor with the magnet marks already cut out inside of there. And then we have here a stator that I've designed to make sure that it was deep enough and had enough coil marks in it that it would work for what we're going to do, because we're going to probably use some really thin magnet wire. And we're going to try to wrap these coils just really thick to see if we can't get the voltage up really quickly with very low RPMs. And I'm not sure whether I'm going to wire this together in delta or star once it's done. We'll kind of play around with the voltmeter once it's up and determine from there which one of those two patterns is going to be better designed for this generator. Alright guys, so there's most of our pieces. Let me go ahead and just change the perspective for you a little bit. You can see some of the other pieces in the background there. So you can see some of the depth to all this. You can see the holes in the bottom of the main case there that the wires are going to come out of. And that can go down the pole that it's going to be mounted on. You can see the depth of the blades there. Alright, so let me go ahead and get these over to a flash drive. Alright, let's take a look at what we've got going on here for our 3D printed wind turbine. I've got a bunch of the machines designated for the project. Let's go ahead and just start out with the Cheedy X-Max 3. We're going to be printing a rear tail fin or rear tail riding vane for the wind generator on the Cheedy, and that's going to be printed out of Cheedy's PETG Tough. It's a great high-speed PETG filament. Over here on the Cheedy X Mark III, we're using Creality's clear glossy material to print out the main part of the case. This is the main body of the case, so you can see how well that's doing. Over here on the Creality CR30 belt printer, we are printing our main turbine blades. And right now, the very first of those blades is being printed. Nice thing about the CR30 is that it's going to print all 5 of those, spit them off the end of the belt when it's done, and they're ready to go. I really love this printer for multiple piece production. Over here, we're going to use the FlashForge Adventure 3 Pro because it does such a good job printing ASAs. We're going to use it to print the rotor and the stator for this project out of the FlashForge ASA, and that's what we're doing right now. So you can see the main magnetic rotor there. We've got our supports inside where the magnets go, and because I have to use so much glue stick on this one, it's very difficult to look through the door because I'm constantly touching it with glue stick covered fingers. And I've got to keep the door shut to keep the internal temperature in there nice and high because ASA really likes to print with a high internal temperature. So the reason we're using ASA for those two parts is they may actually experience a little bit of heat because the coils do get warm when it's functioning. So we're going to want something that can handle a little bit higher temperatures than PETG or something like that. So there you go guys, we've got 4 of our printers right now printing out parts for our wind turbine. Once those parts get done, I'll switch over to the next pieces. I'll show you what those look like, and then once these all get printed out, we'll put them together and see how well our homemade 3D printed wind turbine does out there producing electricity. Alright, so we've just got one more blade to print. We've got the FlashForge over here going to print the stator. Once that's done, all we have to do is assemble this, wrap our coils, install our neodymium magnets. Now I ordered 6 magnets for this, and I thought they were pretty high grade N52s. Turns out these are N36 neodymium, so the power production is considerably less than if we had a much stronger neodymium in this. Alright guys, we've got all our parts printed so we can put together this 3D printed wind turbine. I've changed things up just a little bit. Instead of using that PETG Tough for the rear vane or the rear fin here, I use the Creality PETG Clear Glossy, same with the rest of these parts. I also switched up that white PETG that we had used to print the original wind turbine blades out of and switched over to the PETG Clear. So now we've got all clear parts. We can call this wind generator the Phantom. It's actually going to power a remotely operated security camera that's too far away from the house to run a wire to. So it's kind of perfect that it's all going to be clear, a little more difficult to see. Let's go ahead and start assembling some of this. You can see here we have 2 rolls of copper magnet wire ready to go. This package here is our neodymium magnets. We've got the rotor and the stator right there. And that's where we're going to start. We're going to start wrapping some coils. What we're doing right now is we're building the rotor and the stator part of our wind generator. I figured you didn't want to sit there and watch me wrap a bunch of coils and install them all. Since each one of them is going to be exactly the same process to install, I could just show you the very last one of each of them being installed here, both the magnet and the coil here and the rotor and the stator. Kind of show you how it's done, that way you can figure it out. At the end, I'll show you how to wire the end of these coils together in a series pattern. That way you can get the highest voltage you can get out of this, especially with such a small wind generator. So let's just start with the easiest part of this. We're going to install the last magnet on the rotor. First of all, you can see here, each one of those slots, I've got a magnet installed. Those are glued into place. We've got one open slot. I'm going to show you how you can figure out which way the magnets are going to go, because you don't want the magnets all with the same poles facing out. You don't want random poles facing out. What you want is an alternating magnetic field. So you want a north pole, a south pole, a north pole, a south pole, a north pole, and a south pole. And that's going to give you that alternating magnetic field that we can use to produce an alternating current inside of our generator. So let's go ahead now with our other magnet, and I want to show you what's going to happen here. So this one is going to attract. You can see that kind of holding to my fingers. That is going to be the wrong direction for the slot next to it. You want, when you install these, for the magnets to repel each other when you go to install the one next to that one. And that should also repel from this one as well. The one next to it here, that's also a repulsion. And as long as both of them repel on either side, we should be good. And we can just stick that magnet down in the slot, add a little glue to that, let it dry, and it should be good to go. The next part of this project, let's go ahead and get that out of the way, is wrapping our coils. What I've got here is the stator. You can see, let me try to get that up to the camera for you. We've picked how many of these little dividers that it took, which was 4 on this rotor. We've wrapped our coils in between those, and you can see right now, each one of our coils of the 5 of the 6 are now installed. Now, just like our magnetic field, we don't want each one of our coils wrapped in the same direction. So this coil here is wrapped clockwise. This coil is counterclockwise. This is clockwise, counterclockwise, clockwise, and then counterclockwise. Once again, an alternating magnetic wrap direction with an alternating magnetic pull, a good alternating current output from this. So the last coil I wrapped on here looks like it was wrapping in a clockwise direction, which means this one I'm going to wrap in a counterclockwise direction. So we're going to go ahead and get this going and see how well I can get this on camera for you. First thing I'm going to do is go ahead and take the end of the copper magnet wire here. I'm going to come up from the bottom side of this, and I'm going to pick my gap, and I'm going to feed that copper magnet wire up through there just like this. Once I got a bunch of that through and it's in the right slot inside of the internal part of that stator, I'm just going to fold the end of it over. That way it kind of holds itself there. Then I'm going to go ahead and just kind of fold this all back and get it out of my way. So that would be considered the beginning wire, the start wire to your wrap. Now all I'm going to do to get this wrap going is I'm going to pull this wire. I'm going to measure over 4 of these little teeth. I'm going to put my thumb on it, and then I'm going to put that wire down back through the hole like this, and then catch it over here on the other side with my finger. And now you want to make sure you got it right in the right teeth that you want, just like this. Very hard to show you this with the wire diameter I'm using here in the camera angles. But you're just going to pull it down through. It's now sticking out the other side. I'm going to once again just count how many teeth over that I want, which is 4 on this one. I'm going to hold my finger down on the one side, bring the wire over to the 4th tooth, just like that. Hold it down. You got to make sure you hold these down like that, and then pull it back through the other side. And there we are, right back at our starting position again. And once again, you're going to pull it across the 4 teeth. You're going to want to hold that down with your fingers at the very bottom of the rotor teeth. Push it back through the coil and grab it on the other side with your finger, just like this. Make sure it's in the right groove, and then once again you turn it over, put your finger on top, wrap down that 4th little tooth, and there you are, back out the other side again. And now your coil wires are right back to the beginning, and we've got 2 wraps of our coil inside of our stator. Now I've got to wrap another 23 wraps. Each one of these coils on this particular one is 25 wraps. So each one of these are 25. Let me go ahead and wrap the other 23 wraps off camera. Once that's done, we'll install this inside of the wind generator main case, and I'll get you guys going on the next stage.
Okay, so the next part of this is we're going to need to assemble our actual wind generator head, the actual turbine blades itself, into the actual turbine rotor, which is this piece right here. We have the turbine rotor cap right here. Let's go ahead and get that out of the way right now, and we're just going to focus on these pieces. Let's go ahead and get those four out of the way. We'll start with the first piece here, and we're going to just look for, you can see the holes in here. There's some holes inside the wind vanes. You just line those up. There's actually some flat spots in here that are going to line up real nice with the flat spot on the back of the vane. You go ahead and get one of those aligned for you, and there we are. Now you're going to want to use some super glue or some kind of glue to do this. I'm going to use some number 6 by 32 by 1.5" screws. I'm going to use those to help kind of keep the whole thing aligned as I go around and install each one of these blades. And I'm going to go ahead real quickly here and dry set all these for you, just so you can see how well that goes together. We'll just drop some screws into those holes just to help hold it all together for us. Okay, and the next one. And the final one. And there we go. So now we can see what it looks like once we got all the blades into place. What I'm going to do here is I'll remove one of these at a time. Now that I got the screws and everything holding them into position, I'll remove one of those blades at a time. I'll add some super glue to it, put it back into place, put the screws back in there, kind of hold it, let it set, and then I'll move on, twist it, and go to the next one. Basically, we're going to do this. Go ahead and pull these two screws. We'll pull that blade out. We've got our super glue over here. So let's go ahead and add a little super glue to the top, right there. Flip it around, add a little to the bottom, and a little to this front face right here. You can add a little if you want to these side faces. That'll help hold them all together. Go ahead now and stick that down in there, and I put those two screws back into place to kind of make sure it lines up perfectly. Give it a good set hold and move on to the next one. We'll go ahead and pull the screws on this next one. We'll get that one into place. Add a little super glue to it here again, a little on the top, a little on the bottom, and on these faces. And then once again, we'll just push that into place just like that. Add the screws, kind of get it back lined, and there you go. I'm going to go ahead and just rotate this around and keep going. Now that I got the glue going on there, you kind of want to do this pretty fast, especially because I'm hitting glue on these faces, which touches the other blades. Okay, now for the next one. There we go. We'll put our screws back in there. Go ahead and rotate it again. I have a shot for you there. And our final blade here. Okay, so now that you've got them all in, make sure you kind of go around and press them all in towards each other a little bit and align them. Make sure you got it all nice and centered. You don't feel any loose spots between any of the blades. Alright guys, there we go. Let's go ahead and let that dry. The next step of our wind generator here is to assemble the rotor, the actual magnetic rotor. We're going to use some carbon fiber nylon parts for this. We've printed a carbon fiber nylon rod. This is an 8mm rod that this whole thing's going to drive on. That's 100% infill. Carbon fiber nylon is a self-lubricating material, so this should work pretty well, especially considering we're actually going to be using metal bearings that we're going to push into place. Then we'll run that carbon fiber nylon rod through those bearings. So the rod itself will actually experience very, very little wear or resistance. It'll be free spinning with the bearing itself compressed around it, and the bearing is actually doing all the spinning. So we shouldn't see too much wear with that. I've also got these carbon fiber nylon spacers that we're going to use to get the space between the front and the back of the case and where our rotor sits just right. I've put a carbon fiber top, this is carbon fiber nylon top, on top of the lower bearing. That'll give us a nice smooth face for those spacers to sit on. Just a little something extra. Makes it so it's going to last a little bit longer, maybe run a little bit smoother. So the next part of this is we're going to grab the main part of the case. You can see here I've glued on the lower mount that hooks up to the actual mounting pole that this sits on. We're ready to go with that. We've got a hole in the back of it, a hole in the bottom end of our case, and that's where the wires from our stator are going to come out. You're going to feed into the back right here. We can also go down through the center if we want, but it's a little difficult to get those wires underneath the stator again and down through the center. So I'm going to come out the back and then into this pole, and that'll give us the ability to rotate 360 degrees with our wind turbine. Alright, so real quickly here, let's show you how this all goes together. I've got this spaced just perfectly right now, so the long part of the carbon fiber nylon rod is going to go towards the front where our wind blades are going to connect to. I've got 2 carbon fiber nylon spacers already ready to go for that side. We're going to go ahead and set that into place. The bearing's already pushed in on the front part of the case here. If I can get it to line up, there we go. So we've got that in there. We're going to go ahead and assemble these 2 spacers here for the back. Put those into place, and then I've got 1 smaller spacer that goes in there, a very thin spacer on top of that, and that should give us the exact distance we need. We've got our back panel. Let's go ahead and line that up, and there we go. Let's see if we got any play. Oh, look at that, nice and tight, and spins great. All right, and if you notice, there is, if I hold the case tight, there is just very, ever so slightly, a little bit of back and forth play. We can deal with that. That'll work just fine. So there is the main part of our magnetic rotor. It's now got all the spacers, the bearings are all pressed into place and ready to go. Next step of this is to finish wiring up our stator and then mount the stator inside of the case. I'm going to show you how to very quickly tell which wire from each one of these coils go to what wire on the next coil. And we're going to be wiring this in series, so this will be really easy to do. Right now, I've got our voltmeter. I've got this coil at the tip of my finger. We've got this wire right here coming out of that coil. I'm going to hook that up to our voltmeter. Make sure it's good and connected. And then we have this wire right here, and that one's already connected over here to that side of the voltmeter. So we have these 2 wires coming from that single coil to the voltmeter. You can see the voltmeter over there. I'm going to go ahead and spin the rotor. And you can see a voltage, 0.15, 0.10, 0.18. Way to tell which one of these wires on the next coil to hook up to is very, very simple. Let's just go ahead and take the wire from one of our meter leads, and we're going to twist it to the wire from the next coil. Now you've got to make sure you strip the copper magnet wire coating that's on these wires down to bare copper. You won't have any connection. So make sure you take a little file and strip down any of that red coating that's on there until you actually see bare copper. Wrap those copper ends together. Now once again, let's go back up here. The lead fell off of that one, so we'll rewrap that on. And now we're going to come over and grab the opposite wire from the second coil. So now we're coming from this wire through this coil, out of that wire, into this wire from the second coil, back out of the second coil to where my finger is. We're going to go ahead and wrap the meter to that, just like this, and then we're going to spin the rotor again. And what we should see is either a doubling in the voltage we saw before or no reaction whatsoever. So let's go ahead and spin this. Ooh, look at that. No reaction. Almost no voltage. So that means I've hooked up to the wrong wire. So let's go ahead and switch those wires around. We'll disconnect from the voltmeter real quick on that wire. We'll untwist the 2 we just twisted together. Okay, and now what we're going to do is we're going to twist up the other 2 wires, the one we had to the voltmeter and this one from the first coil. We're going to twist those 2 together now. Give me a second, they're a little thin on the wire. And then we'll hook the voltmeter up to the opposite wire of the second coil. Now when we spin it, if it's connected correctly, we should see a doubling of that 0.12, 0.15 volts. So here we go, let's spin it. Oh, there it was, 0.3. So there's an exact doubling of the voltage that we saw from a single coil. Now I know that I've got the wires from the first coil connected to the right wire from our second coil. Now you can go on and do that same exact thing to the third coil. We're going to go ahead and just connect up to one of the wires. It doesn't matter which one because we don't know which one's actually the correct one at the moment. We're going to connect that. We're going to come over here and grab the opposite wire of that third coil, hook it back up to the voltmeter here, just like that, and we're going to give it a spin and see what happens. Oh, there we go. So we've got a voltage reaction. 4, 5, so we've got up to 0.5, that's a half a volt. We're definitely seeing an increase each time, so I got lucky that time and actually connected the right wires. We don't need to disconnect those other than the meter wire, and we'll disconnect the meter wire from that side, and then we'll go up, pick a wire from the next coil, and do that same thing until we go all the way around, and we see an increase in voltage each time all the way back to the last coil. Now that you've got that figured out, you can come in here and clean this all up. So you're gonna wanna shorten all these wires. Okay, so I've cleaned up all the coils. We've got it all wired together. I've got only 2 wires coming out of our little opening there at the back of the case. We can just give that a quick spin. and we're getting 1 volt. Now hand spinning it, I got a single volt out of it. This little generator is going to be hooked up to a 3.5 volt CR123 battery, so it's not going to need to produce really high voltage. I just wanted to keep that bank of CR123s that are wired in parallel completely full. So what we're going to do now is go ahead and install the rear part of our case here. That should slide right down over it. There's a hole in it for the wires to stick out. I'm going to go ahead and start gluing these all together now that I know everything's connected right. We got our wiring right. Once that's glued down, we're going to go ahead and add the rear cone to it. And this is the cone right here. This will just glue right here onto the back of that. That'll be what it looks like. Then from there, I've got another carbon fiber nylon rod right here that's going to attach right out of the back of that, and that's going to go to our wind vane, and I'll show you all that once it's completed. Alright, our project's complete. I've got the rear vane hooked up to the wind generator, ready to go. We've got our carbon fiber nylon rod running out to that. Everything is wired up to the voltmeter, and we're just waiting for a little bit of wind. It's been gusting all day, so hopefully that'll come up pretty soon. I'll be able to get a good shot of this in action. Just want to walk you around, take a look at it. Fully homemade, 3D printed, functioning wind turbine. Alright, we're starting to get a little bit of wind here, probably about 10, maybe 12 miles an hour. It can't turn right now. The pole it's mounted on doesn't allow it to actually ride in the wind, so it's just going to give us an idea. If I was able to ride, it'd be a higher wind velocity right now hitting it.